Off, Chris.
All right, so what we're going to talk about today is the message operational data store mods. And Chris Carmichael can give you an overview. Kwabena is going to talk about some of the user interfaces and dashboards that are possible. And Jeff's going to run you through the code that makes this work. Next. So what we have is a lot of data that's running through the integration engine. We have got different protocols that run those data that goes through the system. So we've got HL7, we've got FHIR, but the data is kind of the same. It's just in a different format. So you've got patient name in HL7, you got patient name in FHIR, you got test results HL7, test results in FHIR. So it's really just the same data, just a different protocol. So if we had the path to that data, we could populate underlying a data table that could be defined by the user. So you collect only the data that you want to need. So next slide. So with the protocols of HL7 and FHIR and CDA, just getting that path to the data will give us the ability to create that data table. So having these tables that are defined, we can add value to different applications by having known tables that get populated as the data runs through the integration engine. Pre-built tables allow partners to provide that to their customers, where they can also add additional applications that would be based on those tables that are being built within the integration engine. Next, please. So how does this work? So we've got a collection table definition. We need to know the paths to those particular pieces of data that we want to collect. Here we've got the patient test results collection table, and we have properties that represent the data. So we're going to collect patient ID, name, date of birth, sex, order type, value, and unit. And then we've got paths to the data here at HL7 and FHIR. So patient ID numbers in the PID segment, and we've got person.id that's in FHIR. Next, please. So once we have those tables defined, those paths defined, we can have a business process run as the data rolls through the system. And the process will take that path and get the data, and then it will populate the resulting data table. So here, the table that's being created was the patient ID, name, date of birth, sex, and so on. But these values come from both HL7 and FHIR. So really, we're kind of schemaless in this data table, if you will. Next, please. The architecture for this is fairly simple. We're just adding a process that runs off the messages that are flowing through the system. So really, it's just another target where your current messages run through where they normally go, the normal paths they take, with just the addition of an additional target to the table data process. If the process is taking too much resources from the current instance, you can move that off to a reporting server and have all the messages run down there and move the analytics section where you're analyzing the data in the table down to that reporting server as well. Next, please. So is it different than a data warehouse, where a data warehouse does retrospective analysis? This is more of an operational store, taking a look at what's happening in the system right now. So if there's an outbreak of salmonella somewhere, you can immediately find that information and pass it off to the public health services as needed. You could create a data identified research center where you're just having that data that you need to do your analytics. There's no PHI. It's built in upfront without PHI. So you don't have to have a third party tool downstream that's taking that PHI out of the message itself. You can also have predictive modeling and ML training sets where you can take the features of the model and create a table based on those features. And then periodically take that data and feed it to ML training set to keep it valid and up to date. Next slide. All right, that's the overview. I'm going to hand it over to Kwabena, who's going to talk about the interface and dashboards.
Thank you, Chris. So this is an example of a manual UI where you can select a property from a tree structure dropdown and add it to the table. This is done one by one as you move through the schema. Another way to do this same process is by having the LLM find the paths toward the particular data that you're looking for. For example, if you're easily finding the first through fifth properties, but then you need some help finding the sixth, you could just ask the LLM where that data is found in the schema. And of course, this data is going to feed the analytic component of the message operational data store, where you can create dashboards to visualize your data. Regarding patient care, many of these types of data would be familiar to those using FHIR Health Insight, especially the Population Health Analytics dashboard. The real-time patient monitoring dashboard and care coordination dashboard go a step deeper, enabling users to flag abnormal signals in a patient's vitals, promptly intervene, coordinate care for the patient, and track patient progress. The system's operations dashboards generally help to identify bottlenecks in the flow of data from your messages, help you allocate and optimize resource use, help with compliancy and reducing legal risks, and help to identify bottlenecks in your data flow. And for dashboard generation, the idea is that you come with a vision for your data visualization. You can ask agentic AI what kinds of models, what kinds of images would help illustrate what you're looking for in your analytics. And you could use an open source Python library like Streamlit or another framework of your choice to create a data intensive web application. And this should save time and effort for the data analysts that are working on these projects. And now for the backend integration, I'm going to hand it off to Jeff.
Hi, okay, next. So the whole idea behind this is that you create a definition for where the data lives for the different fields that you're going to have in your table. So this can be very dynamic. You would dynamically sort of create this definition of where to find things, as Chris said before, using either AI or drop-down lists, that type of thing from the front end. And then the back end would be responsible to basically iterate through as I get a message in. Say, in this case, I get an HL7 message in. Well, if I have the paths to it, we have a way with like our get at function on this on the schema to be able to go directly to that data piece within the section that we're on in the data. So we can iterate through, we can grab the pieces that we want, and we can put them into the results table as an entry, along with the other entries that come in as well. The next slide. We can do the same thing on the FHIR side. So the FHIR, we basically have the FHIR path APIs within the product as well, so we can iterate through and figure out exactly where a piece of data lives given a FHIR path to that data. So it's sort of the same type of thing. You give a definition of where to find the data, and dynamically we should be able to go through, and for each property we can look and see where to get the piece of data for that, grab it from either the FHIR or wherever. If it's a patient name on one, we can grab that same piece of data from the HL7. From the PID segment, we can also grab the same thing from the resource of the name in the resource itself on the FHIR side. So it gets very dynamic. That allows us to basically populate all the different things that we see here. I'll show you a live demo in a second, but you have the ability to dynamically go through these definitions and say, what properties do we need? And populate those properties given the paths that are in there. Next slide. And before we do that, I'm going to go ahead and share my own screen. This is an example of a FHIR resource that we have here that I pulled through. The other thing is the HL7 message that I wanted to pull through. But then in the engine itself, we just basically have a process files process that you can point things to. So in this case, I have samples of like FHIR or HL7 coming in. FHIR is coming in as JSON. The HL7 is coming in as just an HL7 file. Excel itself, excuse me. And if I run a couple files through there, I can go ahead and grab, say, the HL7 message and copy that and throw it in so that it can run through the engine. And then I do the same thing with the FHIR bundle. Paste that in there as well. So now if I refresh my messages, I see that I have two new ones. I have basically the HL7 file and I have the process files for the HL7N and the other one. If I click on either of these to look at them, on the stream, I can see that I do have a stream that came in. So not a lot to look at there, but on the other side, if I look at the other message and look at it, oops, I did that again. Second time I've done that. I can see the HL7 message that came through and was processed. That means that it should have gone through and populated my table. If I go and look at my table, I have my table here. It's called Demo Super Bowl Table Test Results. And if I execute that query, I can basically see that I have a bunch of rows that have been pulled into us with dates and things like that that I want to. So this just demonstrates the idea that given a definition, we can dynamically go out and build these tables. And the nice thing about it is that you, if again, as Kwabena was saying, if you have an issue figuring out where your data is in those schemas, there's a lot of AI tools and things like that now that allow you to very quickly determine where those are for testing purposes. Thank you very much.
All righty. I'll stop the recording.